Hello everyone, welcome back. Now we are going to discuss on the concept of oblique projectile. Oblique projectile in the sense a projectile throwing a body from the ground making an angle theta with the horizontal. We know that very clearly. And in this case, what we are supposed to calculate and what we are going to learn in this video is we will prove that the trajectory of the projectile is a parabola. What is the trajectory? Trajectory is nothing other than the path followed by the projectile. Projectile is the particle that we throw at an angle theta with the horizontal. And if I throw an object at an angle theta with the horizontal, what maximum height will it reach? And what will be the time of flight? That means the time taken by the particle to, or the total time taken by the particle while it is traveling in the air. That means from the point of projection to reach the ground back again. And what is time of ascent? Time of ascent we have to calculate, where the time of ascent is the time taken by the particle which is projected at an angle theta with the horizontal to reach maximum height. And also time of descent. What is time of descent? The time of descent is the time taken by the projectile to reach the ground from maximum height. And we have to calculate the range of the projectile here. Range of the projectile is the horizontal displacement, and clearly maximum height is the vertical displacement attained by the particle. Here in the diagram, if you observe, we have considered an object which is thrown with an initial velocity u, and this initial velocity is resolved into two components. One u cos theta, the other is u sin theta, as the angle made by the projectile with the horizontal is theta. Now we are talking about maximum height. The maximum height is this. The maximum height it will reach. This is nothing other than the vertical displacement attained by the particle, and the range is the horizontal displacement, which is the distance or distance traveled by the particle in a horizontal direction. This is positive case. So these are all the things we have to calculate, and the time of ascent is the time taken by the projectile to reach from this point here to the maximum height. This is the time taken by the projectile to reach from point O to point which is a maximum height point is what we call it as time of ascent. And time of descent is the time taken by the particle to reach the ground. This is time of descent. This is time of descent. What is time of flight? Time of flight is the total time that the particle travels in the air. This is the total time in which it will be traveling in the air is what time of flight is. All these terms we will be calculating now, and we'll also have to prove that the projectile, the trajectory of a projectile is parabola. The trajectory is this. This is the trajectory of the projectile, means path of the projectile, and we have to prove that this trajectory is a parabola. For this, what I am assuming is, I see we have different sign conventions, meaning taking the values of the distance, velocity, whether you are taking them positive, negative, that confusion will be there. But I am following a simple rule, as I already told you in the previous videos also. What I am taking is along the direction of the motion, whatever I measure, for example, let it be unit velocity, v, or the displacement, or the acceleration, all these terms along the direction of the motion I take positive, opposite to the direction of the motion I will take it negative. And the height, displacement, height is. So in that case, first question we have is we have to prove that the trajectory of the projectile is a parabola. For that, what I will consider is, I will consider the particle after traveling a certain horizontal displacement x and a vertical displacement y, and the time taken for it to travel this vertical and horizontal displacements is t seconds. I assume this. After a certain time of t seconds, the particle is located at this particular point P, where it has a vertical displacement of y as well as a horizontal displacement of x. Now, for calculation of these displacements, I will use for calculation of x, what I will do, I use, this is the horizontal displacement, so I use the horizontal equations of motion for Sx is equal to ux into t plus half into ax into t square. Here we clearly know that Sx is the value of displacement x, ux is the horizontal component of velocity, which is u cos theta, and here ax is equal to 0 because here along the horizontal we have the acceleration due to gravity as 0, but we will only have it along the vertical direction, which is minus g. I'll consider because it is always acting downwards. So I take ax as 0, and remember one more very clear thing: the horizontal component of velocity always will be remaining constant as it is along the horizontal direction. It will always remain, it will be the always remaining the constant because it will not have any force acting on it to have it accelerated. So velocity is a constant always. And in the case here we have ax 0, and I consider the time is t, time is equal to t seconds. So on replacing all these values, what I get is I get x is equal to u cos theta into t, where time t is equal to x by u cos theta. X by u cos theta. Similarly, if I consider for the displacement y, what I get here is I use equation sy is equal to uy into t plus half into ay into t square. Using this equation, if I substitute the values here, what will I consider? Sy is the displacement, that is vertical displacement, which I have considered as y, and uy is the y component of velocity, which is u sine theta. Ay is the acceleration due to gravity, which is always acting downward, so I take it minus g, and I've taken t is equal to t seconds, which is equal to already we calculated, which is x by u cos theta. During this time interval of t seconds only, it is attaining both y displacement as well as x displacement. Y displacement is the vertical displacement, x is the horizontal displacement. Now using these values in substituting in sy, what I'll get is I get it as sy is equal to, sorry, not sy, y is equal to, I get it as u sine theta minus half into u sine theta into t. T value is known to us already, x by u cos theta minus half into g into t square is x square by u square cos square theta. So now u and u gets cancelled here, and what we remain is y is equal to tan theta into x minus g by 2u square cos square theta into x square. So this is the equation of the displacement along the y direction we have. Now if I comparing with the equation of parabola, the equation of parabola is, we know that equation of parabola, which is equal to y is equal to ax minus b into x square. Hence I get the values of a as a is equal to, I get it as tan theta, and we get b is equal to g by 2u square cos square theta. So it is very clear that the path of the projectile or the trajectory of the projectile is a parabola, which is proved. Next thing we have to do, this is question A that we have discussed here. The next thing they have asked us to do is calculate is the maximum height attained, the maximum height. So to calculate the maximum height, I use the equation using vy square minus uy square is equal to 2 into ay into sy. Here the maximum height is the vertical displacement. So the velocity that is responsible for the vertical displacement is initial velocity component is uy, and at maximum height we clearly know that the vertical component of velocity will become 0. So the hence what here we will take is, we will take that vy is equal to 0 because at maximum height, as the particle is thrown into the air with a certain value of initial velocity, what happens, its vertical component of velocity goes on decreasing, and at maximum height its vy component becomes 0. At maximum height it will have only the vx component, which will be always equal to ux, which is equal to u cos theta. The vy value of the velocity vy will become how much? 0 at maximum height. And here Considering that condition, Vy is equal to 0 we take, and Uy is equal to, we take it as U sin theta, the one which is responsible for the vertical displacement. Ay is always acting downwards, so I take it as minus G, and Sy is equal to, I consider it as H. So substituting these values in the equation above, what we'll get is, we get 0 minus U square sin square theta is equal to minus 2G H. So H value will become, now H will be equal to, I write it as U square sin square theta by 2G. Also we can also write it as H is equal to Uy square by 2G, because we know very clearly that Uy is equal to U sin theta. So just replacing it Y component, I'll get it as Uy square by 2G as the height of the projectile. And here we also can we now calculate the time of flight. The time of flight, I represent it with the letter capital T. The time of flight is the total time for which the particle remains in the air. So for that I use equation using Sy is equal to Uy into T plus half into Ay into T square. Here if you observe, Sy, while that particle, Sy, the displacement, the vertical displacement for the total time interval for which the particle starts from the point O and it reaches the ground back again. For this, the vertical displacement when the particle reaches the ground, after the particle reaching the ground, after T's total time T, the vertical displacement will become 0, Sy will become 0. So using Sy taking 0, here if I take Sy is equal to 0, and Uy we know it very clearly, which is U sin theta, and Ay is always acting downwards, which is equal to minus G, and time of flight is T is equal to capital T, I consider, and what I get is 0 is equal to U sin theta into capital T minus half into G into capital T square. So half G capital T square is equal to U sin theta into T. So where here T and square gets cancelled out, and what I get is time of flight is equal to 2U sin theta by G. 2U sin theta by G. Even we can write it as T is equal to 2U sin theta means 2Ux by G, because we know very clearly that Ux is equal to U, sorry, not 2Ux, U sin theta is Uy by G, which is Uy is equal to U sin theta. Next thing we are supposed to do is calculate is the time of ascent. Which I represent it as Ta. The time of ascent is the time taken by the particle to reach maximum height. We clearly know that at maximum height, Vy is equal to 0, that vertical component of velocity is equal to 0, and using the equation Vy is equal to Uy plus Ay into T, and here the values of Vy will become 0, Uy will be equal to U sin theta, and Ay is always acting downward, which is minus G, and time T is equal to, I consider it as Ta. Here 0 is equal to U sin theta minus GTA, and the time of ascent Ta is equal to U sin theta by G, which also can be written as time of ascent is equal to Uy by G. Next, time of descent. For the calculation of time of descent, we assume that the particle is under free fall at maximum height. I consider the initial velocity at maximum height when it is under free fall is equal to 0, because when the particle is under free fall, its initial velocity will be 0. So I take Vy using this equation, which is using Sy is equal to Uy into T plus half into Ay, so Uy dash into T square, because I can use again Uy itself here, but I already considered Uy as the vertical component of initial velocity. But here, as we are considering for the free fall of the body, the time taken for the particle to reach the ground from maximum height, what I consider it as Uy dash, which is the initial velocity of a body which is under free fall, which is always 0. So I consider uy dash is equal to 0, and sy we know it very clearly, which is h, height, vertical displacement, which is measured from the top of the from the maximum height. We are measuring it downward the time. So we have to take it a minus u square sine square theta by 2g, and ay is always to be measured downward, so minus g, and t I am replacing it as td. So using all this, what I get is minus u square sine square theta by 2g is equal to minus half g td square. So this minus minus gets cancelled out here. So now I'll get it as td square is equal to I get it as 2 and 2 also will get cancelled out. I get it as u square sine square theta by g square, from which I get it as td is equal to u sine theta divided by g. From this we can clearly tell that time of ascent is equal to time of descent, which is equal to u sine theta by g, or also you can write it as u y by g. This is time of flight, or you can consider the time of total time of time of descent is equal to time of the ascent, and time of flight is time of ascent plus time of descent. That means time of flight is equal to 2u sine theta by g, or you can also write it as 2uy by g. It is the same again. Next we are supposed to discuss the next we have to discuss about the range of the projectile. What is the range? Range is nothing other than the horizontal displacement. Range is horizontal displacement, range r. So horizontal displacement is r, range is equal to, I just take it as ux into t. That means the total component of velocity which is responsible for the horizontal displacement into the total time taken for the particle. So r is equal to, I take it as ux is known to us, which is u cos theta, into, we know that uy total time of flight is 2u sine theta by g, from which I can write it as range of the projectile r is equal to 2 into or u square into 2 sine theta cos theta divided by g, from which I can write range of the projectile r is equal to u square sine 2 theta by g, because since 2 sine theta cos theta is equal to sine 2 theta is the formula. So this is the formula for range. Here range is maximum, or range can be maximum when sine 2 theta is equal to maximum. What is the maximum possible value of a sine function? It is 1. So sine 2 theta is equal to 1, then range will be maximum. That range maximum will be equal to u square by g. So what is the angle for which the range will be maximum? 2 theta is equal to sine inverse of 1. So 2 theta is equal to 90 degrees. So theta is equal to 45 degrees. If the angle of projection is 45 degrees, then is when the range is maximum. So for what angle of projection we will have the range maximum? For the angle which is 45 degrees is when you will have range as maximum. There is one more condition we have to remember about range here. Range is same for two angles of projection, meaning if you are projecting a particle with respect to the horizontal at two different angles, the range will be same if you are projecting the bodies with the same initial velocity of projection. What are the two angles? That is called as complementary angles. That means the sum of the two angles should be equal to 90 degrees. For example, if you project theta 1 is equal to 30 degrees and theta 2 is equal to 60 degrees, then is when you have the range same. You have the same range. Similarly, for theta 1 is equal to, if you take 37 degrees, theta 2 will definitely, the range will be definitely be equal to the same range as you got it for theta 1, which is 37 degrees, for the other angle as 53 degrees. So the range can be possibly same at two angles of projection with the same velocity. What is that two angles called as? Complementary angles, where their sum will be always equal to 90 degrees. Hope you understood these concepts on the horizontal oblique projectile. So I'll be coming up with again different videos on horizontal projectile, where we will be calculating all these quantities again, which is the maximum height, time of flight, range of the projectile for the case of an object that is thrown up the inclined plane, down the inclined plane. And we will be solving few more numericals on these models as well in the coming up videos. So for more updates on each chapter wise videos, short videos, or conceptual videos, please do like, share, comment and subscribe our channel. Thank you.